our powers combined, we summon Captain Planet!
How did you get in here?
The Physiteer's commitment to science brought me here to defeat you.
You can't defeat me. My plans are too diabolical. Plus, we've had a dependency on oil for decades now, and there's no end in sight.
Yes, there is. Eco-awareness is spreading. Physiteers, can you offer some examples of being eco-friendly and saving energy?
Take showers instead of baths.
Carpool.
You can turn the lights off when you leave our room.
How about the audience? Does anyone have ways of saving energy and being eco-friendly?
Ride a bike.
Anybody else?
Cycling.
Cycling.
It's great.
You see, Professor Payne, eco-awareness is spreading. Your end is near.
Don't be so sure.
Miss Fortune told us all about your doomsday device.
She couldn't even remember how to work the Tesla coil. You thought it was clever, siphoning energy from every major city in the world and storing it all in one place? Such a typical villain.
Now we call on the power of Captain Planet to destroy it and defeat you once and for all. All the energy you stole will be returned to be conserved and used wisely.
I will return the energy that you have stolen from whence it came, and soon this barrel will implode. Grad student, some assistance. So what we've done here is we've been boiling some water within this oil drum. Now, on top we have a basic on-off gate valve, and while boiling water, we left it open. As the water boiled, it produced steam, and that steam pushed all the air out of the barrels. Now what we've done is we've closed off the valve, and we are now rapidly cooling the steam inside the barrel. As that steam cools back down, it goes back into its liquid form, and that reduces the pressure inside the barrel. Now the atmospheric pressure outside the barrel has stayed constant, and rather unexpectedly, in a timely manner, the atmospheric pressure will overcome the pressure, and how sturdy the barrel is, and the barrel will implode.
I don't think you guys can do this. You don't know how it works.
You think you had it all figured out.
I do. Captain Planet knows what he's doing. You know what he was doing when he got that haircut?
Possibly.
One of our favorite demonstrations. It's quite unpredictable. In fact, this morning I started saying exactly this, and then it blew up right on the spot, right in the middle of my little speech explaining why it's unpredictable. So I'll try it again, and maybe it'll go off. It can take anywhere from a couple minutes to as long as half an hour before it actually happens. It depends on the strength of the barrel, depends on how much water we actually got to boil, and how much steam escaped. But as Captain Planet told you, what has happened is all the steam that was inside the barrel has condensed into liquid, and thus takes up much less space. Since the valve is closed, the air cannot come in anymore, and that's why the pressure has gotten a lot lower. We have a pressure gauge on top, and we can see that the pressure has been dropping steadily. So as long as it continues to drop, we're probably going to have it imploded here at any moment. But it could take a while. So at this point, I think we'd like to open up the floor to questions. If anybody has a question about what they saw today, or about physics, or about studying physics, raise your hand and we will answer your question. In the back?
What was the rod made out of that made the Mylar
That's just a cardboard tube. It's really good at keeping, it's an insulator, so when charges go on the outside, they stay there. They don't move very easily through the material.
So it's just a cardboard tube like
Oh,
With a rubber band.
Yeah. Oh, you mean inside the material? There's a rubber band that goes on moving past a little piece of wire that strips off electrons as it moves on the belt, and then that makes the whole thing charge.
Is it something that
Yeah. You make it.
Principle, yeah.
You can buy it.
You would just need a simple motor to drive the belts around, and then a piece of cardboard to take the charge. Did you have a question over here?
When we start a fire at home in a fireplace, not the fireplace, the wood stove, we've noticed there's different colors of flame.
Mhm.
And I noticed there are different colors from the different salts.
That's right.
So what's causing the different colored flames when we get a fire going on fire in that wood stove?
That's a good question. It's mostly related to the temperature of what you're burning. So actually blue is the hottest flame that you can see. So if you take a chemistry class, the Bunsen burners you use have a blue flame. That means it's extremely hot. Burning wood happens at a much lower temperature, and so it's more of an orange colored flame. It's related to the amount of energy that's being released per second, so the energy output of what's going on. So the hotter flame is a higher temperature, and that's why it's hotter. Cooler flame is, well, still relatively warm, but it's going to be an orange temperature. And then below orange would be, say, red. And if you've ever heard of the electromagnetic spectrum, you have your visible light, which is your rainbow, that goes from red to purple. And then that also relates to temperature. So the red end is the coolest, and the purple is the hottest. If you go beyond the visible part of the spectrum, you get the infrared, and that's even cooler. And you can go beyond the other side and get into the ultraviolet, which is even warmer. So the fire is just a manifestation of that color.
So where would the green come in?
Green's right in the middle. And so it would be warmer than orange, but cooler than blue, for example. Mhm. Anybody else have a question?
I have a question about the Tesla coil.
Okay.
I mean, going into the electrical source here, how is it generating that much energy and voltage to create lightning? I mean, I'm calling it lightning.
That's basically what it is. Do you want to take this one?
Sure. Does anyone here know what an inductor is? All right, we have a couple nods. An inductor is, I don't have test coils right over there, so actually here.
Quick interjection, we're running a little low on time right now, so I'm gonna give this a little tap.
I'll explain this afterwards.
Possibly,
A little tap.
yeah.
This is a very strong barrel. This one may not go.
Yeah, it may not go.
They just make them too strong these days. It's
Can you
unfortunate.
put it on the side where you have to put it on the rings?
Oh,
It's not. Wow. When was the last time that happened?
it's happening quite often.
Well, it looks like we're going to have to find some new eco-friendly solutions. Since, we weren't able to implode the barrel and return all the energy from the cities in the world. But I'm confident with all of your help that this can happen.
I am so proud of my physicists. You all showed great courage and intelligence, but we must continue to work towards our goal of energy conservation and eco-awareness. I think it is time that we expand our ranks. Thus, I hereby promote everyone in this room to the rank of Physiteer. Your mission, should you choose to accept it, is to spread the word. Share what you have learned here today with your friends, family, and neighbors. Only together can we defeat the powers of evil and wastefulness. And remember, wherever you go, Captain Planet and the Physiteers will be with you in spirit.
Ready? Everybody?
1, 2, 3.
The power is yours.